Design teams today are locked into closed platforms and rapidly compounding subscription costs. You build your entire design system inside one vendor's ecosystem, and the price of leaving becomes too high to even consider. But the cost is only half the problem. If you look at how legacy tools operate, they rely on a specific technical shortcut. They render graphics on an HTML canvas element. Every button, shadow, and text box gets flattened into a single image layer. This creates a hard translation gap between the design tool and the actual internet. The canvas looks like a website, but underneath, it doesn't use the structural languages that web browsers actually understand. Because the design file is essentially a highly interactive painting, developers cannot pull usable layout structures directly from it. They have to look at the visual abstractions and manually reverse engineer them into functional, coded components. This is where the developer handoff breaks down. Designers spend weeks perfecting a layout, only for developers to waste hours trying to eyeball margins and recreate the exact same logic in CSS, leading to inevitable front-end inaccuracies. The friction scales as the company grows. When engineering teams try to build automated continuous integration pipelines, those design files remain completely opaque to the codebase. The computers can't read what the designers drew. Solving this requires an architectural inversion. Instead of building a better canvas, the goal is to eliminate the canvas layer entirely. The biggest bottleneck in digital product development isn't the interface of the design software. It is the underlying rendering architecture that artificially separates the people drawing the product from the people building it. This exact problem is why an open-source platform called Penpot has accumulated over 47,000 stars on GitHub. Penpot operates on a philosophy of design expressed as code. It uses native web standards like SVG, CSS, HTML, and JSON right out of the gate. To pull this off, the platform runs on a backend built in Clojure and WebAssembly. This combination generates a true document object model, or DOM, environment right inside the workspace. This presents an immediate dilemma for teams considering a switch. Moving to Penpot means abandoning a highly refined, frictionless cloud tool for an open-source alternative. There is a real fear that migrating to a self-hosted, code-native platform will introduce massive setup friction or completely break the workflows your agency has spent years optimizing. Deciding if Penpot is the right choice means looking past the appeal of free software and evaluating the actual, unglamorous realities of server deployment, tool ecosystems, and your specific team structure. Let's start with the first core trade-off, the developer handoff and rendering accuracy. This scorecard visualizes the difference in inputs. On the left is the standard canvas tool. On the right, Penpot builds layouts using native CSS Grid, Flex Layout, and true SVG rendering directly in the browser. The practical outcome here is extreme accuracy. Because designers are building with the actual building blocks of the web, developers can inspect the file and extract production-ready code that matches the design's behavior exactly. Penpot integrates native design tokens directly into this structure. This creates a strict one-to-one single source of truth. Change a spacing variable in the design file, and it instantly syncs across both the design system and the development repository. The trade-off is hardware utilization. Rendering thousands of true DOM elements and executing CSS calculations inherently consumes more system memory than painting a single flattened canvas frame. If your current workflow involves a single, massive file containing hundreds of dense artboards, Penpot will likely lack the hyper-optimized smooth panning you expect from legacy desktop applications. The browser has to work harder to maintain all those individual DOM nodes. However, if you break your work into smaller, modular design systems, performance stabilizes. This approach aligns much closer to modern component-driven development. You are intentionally trading infinite canvas smoothness for absolute mathematical accuracy during the development phase. The second axis of evaluation is data sovereignty and infrastructure.
Looking at this updated diagram, Penpot gives you the option to deploy the platform entirely on your internal servers using Docker or Kubernetes. By cutting out the third-party cloud, you achieve 100% data sovereignty. Your files live on your hardware, making your company immune to sudden vendor price hikes. This solves a critical problem for companies in healthcare, fintech, and government. When strict compliance protocols forbid storing intellectual property on external clouds, A self-hosted design tool is often the only legal option. The trade-off here is operational reality. Taking the self-hosted route requires dedicated internal DevOps resources to keep the platform running securely. You have to troubleshoot Nginx configurations, you have to handle upload errors, monitor container health, and execute your own database backups. If the server goes down, your design team is paralyzed until your engineers fix it. Penpot does offer a managed SaaS version if you want to skip the setup. But taking the self-hosted route effectively shifts expenses from software subscriptions directly into dedicated engineering hours. Self-hosting provides a strategic advantage for security-first enterprises, but it can be a significant time sink for smaller design agencies without dedicated IT support. The final axis of evaluation is extensibility and the tool ecosystem. Penpot recently integrated a Model Context Protocol, or MCP, server. This is an open standard designed to make data sources readable by artificial intelligence, turning static workspaces into programmable environments. As the diagram shows, the MCP server allows you to connect Penpot's open API to external AI agents. This facilitates multi-directional workflows where code and design talk to each other. Because Penpot is built on native web standards, AI agents can actually read the underlying DOM structure of your layouts. You can write scripts that command an AI to audit a massive file, find inconsistencies, and automate complex design system updates instantly. The trade-off is accessibility. Leveraging the MCP server to build these pipelines requires significant scripting expertise. Right now, Penpot lacks the massive, frictionless marketplace of community templates and click-to-install plugins that designers relying on legacy platforms use every day. You lose the consumer convenience of searching a store to solve a minor layout problem, but you gain the enterprise power of writing custom logic to manage thousands of components automatically. You are trading immediate out-of-the-box convenience for deep infrastructural programmability. Choosing Penpot requires mapping your specific pain points against these strict trade-offs. Looking at this decision tree, if you are a must-switch organization like fintech, healthcare, or government, compliance dictates your software. The ability to deploy Penpot entirely self-hosted makes it the definitive choice. If you are a developer-heavy startup where the handoff bottleneck is killing your velocity, Penpot is highly recommended. Using the cloud-hosted SaaS version gives you the CSS Grid accuracy and native design tokens without the DevOps overhead. But if you are a traditional UI/UX agency or solo freelancer relying heavily on massive plugin libraries, you fall into the hold-off segment. The lack of a mature template ecosystem will slow you down more than the DOM rendering speeds you up. Penpot serves teams scaling digital products who need a specialized engine more than they need a general-purpose replacement. Before you initiate any tool migration, audit your internal DevOps capacity and verify exactly where your developer bottlenecks are occurring. Adopting true open-source architecture means taking full ownership of your workflow. You control the platform's power, but you also assume responsibility for its maintenance. If this saved you time, hit subscribe. We review tools like this every week, so you're always ahead. Now, if you liked this open-source design tool, you're going to love our breakdown of Awesome Design MD. Relying on a single vendor for core infrastructure is a choice, not a requirement. You just have to decide if your team is ready to own the bridge between design and code.